Next, let's look at multivariate normality. Now, multivariate normality is a tricky subject. It will nearly always be present to some extent, but there's not a lot you can do about it, and most tests are overly strict and tend to over-reject due to sensitivity to things like sample size. So typically, if you have univariate normality, then you can be fairly confident you have adequate multivariate normality. Nevertheless, if you'd like to estimate something like a Mardia's, you can use a reasoning model in ChatGPT. Let me show you how to do that. So if we go back to our model, you can see we have this basic model. You can use either the CFA or the structural model. Doesn't actually matter for this test. But if I go back to the report, this is just a regular algorithm, not a bootstrap. But I can create a data file. So create data file, and I'm going to export the manifest variable scores. And I'll just call this manifest and create. It creates that data set. If I go back and back, then you can see I have this manifest data set. It looks like it's retained only 188 rows, but that's because I did it for just one of the groups. Let's go back and do this for both groups. Open this up, calculate this regular algorithm, and in the data, make sure to do it for the base group, not for these individual groups. Start calculation, go to create data file. Again, let's go manifest all, and do the manifest variable scores, create, go back, and you'll see we now have manifest all with 381 data points. Double-clicking it, and then going to the export to Excel or CSV. I'll just stick this on my desktop and call it manifest variables. And here they are. I'm just going to close that and go back to ChatGPT and give it that file. Drag this up here and say, here are my manifest variables. Please assess multivariate normality. Please notice that I am using a reasoning model. The O4 Mini High is the best one at the moment, aside from O3, which takes forever. But I have tried O4 Mini High a few times, and it does produce correct results. I would hesitate to use a non-reasoning model, such as O4. You need it to be able to think about it. Here we go. Okay, it's going to look at univariate first, because univariate is part of multivariate. And it shows those values that we already have seen when examining this. If you want to check these against what SmartPLS shows, you certainly can. And it says we're good here, and we're good there, good for skewness, good for kurtosis, except possibly skill acquisition items, which we knew would have some kurtosis. We saw that earlier in a different video. Nevertheless, it says univariate statistics do not alone guarantee multivariate normality, but they do suggest that that factor, skill acquisition, might be less than normally distributed. But if we look at Mardia's, here are the formulas, lots and lots of stuff, and it's going to tell us what it means. It says that both of these are significant, indicating that these are not normal. They significantly deviate from multivariate normality, and that that's likely due to skill acquisition. So if we're going to do CB-SEM, it says you probably ought to use not just the regular maximum likelihood, but maybe a robust estimator, such as the Sartoro-Bentler scaled chi-square with robust standard errors, or Bootstrap, which is what we have access to in SmartPLS. Either way, we ought to probably report the Mardia's statistic just to show that we have addressed multivariate normality.